One of the best tools for making decisions and predictions is probability distributions. So Chapter 5 is going to talk about discrete distributions, and Chapter 6 will talk about continuous distributions. Remember the difference between discrete and continuous? Discrete variables were basically integer variables like number of customers, number of airplane takeoffs, number of customer calls, whereas continuous would be things with a fraction like sales, market share, profit, revenue. So we'll start with some examples here. Discrete distributions, number of takeoffs for an airline, number of customers for Netflix, number of service calls. So if I were to ask you if that was discrete or continuous, those are all discrete variables. So that's the only difference between chapters 5 and 6 is basically they're splitting up discrete distributions and continuous probability distributions. So this is going to tell us things like, if there's too many customers, too few customers, too many service calls, that helps me make decisions about, well, maybe my system isn't working appropriately. Okay, so we're not going to cover uniform distribution. It's really not that likely. What uniform distribution means is that every possibility is equally likely to be chosen, and it's pretty unlikely to have, one customer coming into Starbucks being equally likely to 15 customers coming into Starbucks. So we're not going to cover uniform distribution, but we'll cover binomial and Poisson after we cover some foundational material for discrete distributions. So it helps us understand business processes, and we can think of it as doing repeatable random experiments. So you can think of someone observing on 10 different days how many people come into Starbucks. That's basically a repeatable random experiment. I'm observing how many people come into Starbucks so that I can make decisions about how many baristas to have on. So some other examples is maybe, rolling a die 3 times, flipping a coin 10 times, but more business oriented, observing the number of customers on 10 different days, maybe observing how many TVs or iPads are sold over 100 days or over, 10 quarters. Okay, so a discrete random variable. Upper limits we don't always know for sure. For example, we might not know the maximum number of customers that will come into Starbucks on a given day or a given hour. We don't know the maximum number of takeoffs in a given day at Denver International Airport. Some examples: customers, service calls, and takeoffs. So the distribution from these probabilities follows some basic probability rules. So basically, if you have a probability of, say, 10 customers coming in, well, the probability of not 10 customers or anything but 10 customers is just 1 minus the probability of 10 customers. So that's going to help us a little bit later on. It's called the complement rule, where basically, the probability of having or selling 12 TVs is the probability, or is 1 minus the probability of selling anything but that. So that'll come into play a little bit later on. We assign probabilities to each value of X. So the probability of 2 customers coming in might be 50%, whereas the probability of 25 customers might be 8%. So each value of X is not going to have the same probability, which makes sense. It's not going to be just as likely for 25 TVs to be sold as it is for 1 TV to be sold. Okay, so if we're given a discrete random variable, let's say number of customers is X, each value for X, like 2 customers, 3 customers, 4, will have a probability. So we represent that with the P of X, and we can determine what we expect X to be, which is just another way of saying the mean. So basically, this is the equation, but we can do this easily in Excel. But I just want to show you that it's basically each value of X. So basically, 1 customer, 2 customer, 3 customers times its probability. So times how likely it will occur. And when you add those up, you get an expected. So, 0 customers and the probability is 20%. 2 customers, probability is 30%. I multiply all those and add them up, I get an expected number of customers. So that's basically another way of saying average. Again, that's called expected value, and that's for discrete random variable. Okay, so let's look at an example. I observe the number of customers that come into Starbucks from 6 a.m. to 7 a.m. And I do that for 10 days. So there's 10 total observations. I observed 0 customers on 0 days. So basically, there was never a day that had 0 customers. Okay? And the rest of the data looks like this. These are the different values that X could have. So 0 customers, 1, 2, 3, 4, and 5 customers. And then how often it was observed, with the total being 10 observed days. So notice those numbers have to equal 10 because I had 10 observations. And you want to assign a weight to each customer depending on how probable it was. So 5 customers was the most likely, so I want to put a weight to that. Notice how I wouldn't want to get an average just by doing 0 plus 1 plus 2 plus 3 plus 4 plus 5 divided by 6. That's not a good average because each of these has either more or less likely to happen. So I want to put more weight on the 5 and a lot less weight on the 0, 1, and 2. Okay, so the next step is to find those probabilities. I'm basically just dividing how many times I observed it over the total. So just like a typical probability equation, 0 over 10 equals 0. And you can see 20% likelihood of having 3 customers, 30% likelihood of having 4 customers, and 50% chance of having 5 customers. So I want to assign more weight to that 5. And again, I observed for a total of 10 days, so that should equal 10. And all probabilities should add up to 1. So I'm checking that, and it comes out right. Okay, so to find the expected value or the mean is basically just the total once you've multiplied all your x's by your probabilities. Okay, and a good function in Excel to do that is sum product. So I'll demonstrate that next.